السلام عليكم ورحمة الله. تمرين لطلبة المدارس ثنائية اللغة. The figure below shows an ideal transformer connected to a globe. This is the globe, and this will be the secondary coil. So here we have NS, because any resistor or any globe, light, a machine, always connected to the secondary coil. And here we have the primary coil, then we have NP. It says the ratio of the primary to secondary turns of the transformer is 1:5. So the ratio of the primary coil, so NP, to the secondary coil NS equals 1:5. Then we can say that NP over NS equals 1/5. This is how to deal with it. This is the source of the voltage, and then the 12 volt is the VP. The voltage in the primary coil is 12 volts. Part A. Name the two types of the transformers. We have a step down transformer and a step up transformer. You just need to write them down. Then we have another questions or another parts connected to this question. Part B, calculate the voltage across the secondary coil. As I said before, there in the figure, we have VB equals to 12, and we have also the ratio NP over NS equals to 1/5, as stated before. Then, if I want to calculate the voltage across the secondary coil, so I need to calculate VS, because secondary S here. Okay, let's calculate it. Then we can say NP over NS equals 1/5, which is equals always NB over NS equals VB over VS. Then we just multiply them side by side. Then VS times 1 is VS equals to 5 VB, and this is equals to 5 times VB is 12. Finally, VS equals 60 volts. 5 times 12. Part C. If the resistance of the globe is 2 ohms, so the resistance of the globe, calculate the power of the primary coil. Always the power in the primary coils, or the power in the primary coil equals the power in the secondary coil. So if I want to calculate the power in the primary coil, I can calculate it. P equals IP times VP, but I don't have IB. I have VB, which is 12, but I don't have IB. IB is missing. But as long as the power in the primary coil equals the power in the secondary coil, I can calculate the power in the primary coil by calculating the power in the secondary coil. So the power in the secondary coil equals IS, the current in the secondary coil, times the VS, which is the voltage in the secondary coil. Again, I don't have VS, but I have the resistance in the secondary coil. then I can say that IS equals VS over R. Then I put them here. So IS equals VS over R times VS. We can write it as follows: PS equals VS square over R. Then I have just calculated VS in the part P, which is 60 volts. So 60 square over 2 equals 300 or 3600 over 2, which is 1800 watts. This is the power in the secondary coil, and according to this I can write that the power in the primary coil equals the power in the secondary coil, which is 1800 watts. Last question, or last part in this question, part D. If a diode is connected to the previous transformer as shown in the figure below, what will happen to the globe? Explain your answer. So by putting a diode in the circuit of the secondary coil, it will become a circuit of a half wave rectifier, because as long as here I have an alternate current, I have also an alternate current in the secondary coil. That means at a time the current comes from this side, and after half a period the current comes from that side. Let me just remove this. The current can come from this side for a half period, and the other half the current comes from the other side. And then when the current comes from this side, it will not go through the diode, then the globe will be off. But when the current comes from that side, the current can go through the diode and the globe can be on. Then what will happen? The globe will turn on and off because the half wave rectification. This is the full answer of this question. See you at another questions.